What's up, guys? Mr. C here with lesson 9.5. This is our last section of the chapter. Going to be talking about geometric series. Remember, a series is just a sum of a collection of terms. It's basically taking a sequence and adding all those terms up together. And geometric was when there's a common ratio, not a common difference, meaning we're multiplying between terms, not adding or subtracting. So let's go ahead and look at my formula for my sum. All right, the sum of a geometric sequence is going to equal the first term times 1 minus r to the number of terms there are, r being the common ratio, n being how many terms there are. Right? Remember, common ratio is just the number you're multiplying by between each term. Right? And that is going to be my formula. So let's look at this example down here. Find the sum from when n is 0 to n is 20 of, this is my rule for finding the terms. Okay, 4 times 1/2 to the nth power. Okay, so things we need to find is the first term, the common ratio, and then the number of terms. Right? Let's first find n, okay, the number of terms, because I think that might be a little tricky. We might be tempted to think that there are 20 terms, but there's technically not 20 terms. From 0 to 20, there's actually 21 terms, right? From 1 to 20, there's 20 terms, but from 0 to 20, there's 21 terms. Okay, so that's when n is 21. Common ratio, r, is, well, think for this rule, we're multiplying by, depending on what n is, we're multiplying by 1/2 each time, right? So it'll be 1/2 times 1/2 times 1/2, depending on what n is. So my common ratio is 1/2. A sub 1. That's my first term. If I was to plug in my first term when n is 0, if I was to plug in 0 here, okay, 1/2 to the 0 power, remember anything to the 0 power is 1. 1 times 4 is 4. So my first term is going to be 4. Okay, so those are the three things I need. Let's plug those into the formula. My sum is going to equal a sub 1, which is 4, times 1 minus r to the n over 1 minus r. So this is 4 times, let's figure out what 1 minus 1/2 to the 21st is. 1 minus, oops, let me do it this way, 1 minus 1/2 to the 21st power. I think 1/2 to the 21st power is probably going to be pretty small. It's like 1/2 times 1/2 times 1/2. So this is about 1. I'm okay with us rounding that to 1 there. Over 1 minus 1/2 is also 1/2. So this is 4 over 1/2. And think when we divide by a fraction, the rule is to multiply by its reciprocal. So this is equal to 4 times 2, which is 8. Okay, so my sum there is going to be 8. All right. Okay, hope we followed. If not, let me know, ask me any questions, but that is our formula, and that's how we would do that one. Next thing I want to talk about is, well, before I do that, if you'd like to start today's homework, go ahead and do that now, and then you can continue on the rest of the video later. So let's go ahead and continue. So let's talk about an infinite geometric series. So this is a little bit tricky to wrap our minds around, an infinite geometric series, because we're finding the sum of an infinite amount of numbers. So you might be tempted to think, okay, if I'm continually adding a number, isn't that going to just be infinity? Like, for example, if I take the sum of an arithmetic sequence, this arithmetic sequence, 1, 2, 3, 4, 5, 6, and so on. Okay, and I do that all the way to infinity. Okay, and I find this sum, you would be right to say that, okay, well, if I continue to add numbers, this is basically just going to be infinity. Like, how could this be anything other than infinity? Okay, The term that we use for a series like this is this series diverges. Okay, this series diverges, meaning it doesn't actually have a sum. Right? Now, there are certain geometric series that do actually converge at even when they're infinite. Okay, it's crazy. So think about a series like this: 1, 1/2, 1/4, 1/8, 1/16, 1/32, 1/64. I think you get the idea, and so on. Okay. Really, technically, this is what 1 over 2 to the n power. Okay, that's what we're doing here. So this series actually converges and it has a sum, has a definite sum. Even though you're adding an infinite amount of numbers to it, the term is called converges. Let me write those two terms down so you see them. Diverges and converges. This thing actually converges and you can find a sum to it even though you're adding an infinite amount of numbers. We're not going to get too in-depth into why that happens because that requires some calculus, and probably if you take pre-calc with me, we might get to talking about this stuff, why it actually converges. It's really interesting to me that something infinite can actually, if you add it up, converges to a single number. So let's go ahead and do a couple of these. This is my formula for a, well, I should preface this. So let's read this. An infinite geometric series with the first term a sub 1 and a common ratio r, if the common ratio is less than 1, or at least the absolute value of the common ratio is less than 1, then the sum is finite. So I shouldn't say all infinite geometric series converge. As a matter of fact, most of them probably don't. Okay? Most of them are going to diverge. The way that they're going to converge is if your common ratio is less than 1. Like, well, the absolute value of your common ratio. Like 1/2, 1/4, -1/8, -1/7, something like this. These are all the absolute value of those numbers are all less than 1. Think about it this way. Remember when we went over exponential equations? Okay. Really, the difference is this exponential going to be exponential growth, or is it going to be exponential decay? You guys were really good on picking that up. Basically, if it's going to be exponential decay, it's going to converge. If it's exponential growth, it's going to diverge. Okay, that's basically what's going on here. Right? So again, if the absolute value of r is less than 1, it's going to converge. Okay, and it does have a sum. And this is the formula for finding it. So let's go ahead and do an example. This will be the last thing we do today. Well, we'll do two examples. Does the series converge or diverge? Okay, does the series converge or diverge? Let's say I have 1 plus 1/2 plus 1/4. This is that example we just went over, so this is kind of silly, but we are going to find its sum. Okay, this is an infinite series that will continue to go on forever. Does it converge or diverge? Well, what's the common ratio between each term? What am I multiplying by? Okay, what is r? From 1 to 1/2 to 1/4 to 1/8, you are multiplying by half. So if r is 1/2, that means this is going to converge. We can actually find its sum using this formula. Okay. A sub 1 is 1 over 1 minus 1 half. This is 1 over 1 half, which is 1 times 2, which is 2. Okay. So this series is going to converge to 2. And you can see that because r is 1 half, you know it's going to converge. The sum actually converges to 2. If you were to add up this infinite amount of numbers, it is equal to 2. Okay, which again, I know is really weird. You're adding an infinite amount of things. It's basically because, I mean, think about it. Once you get all the way down the line, 1 over, what's the game? 2048 will be there. 1 over 4096. These numbers kind of become so minuscule that it doesn't have much effect on your sum. Okay, which is kind of why these ones converge rather than diverge. Okay, that's kind of a non-mathematical, well, it's mathematical, but it's non-proofy way to kind of understand why these converge versus diverge. Okay, so that's that one. Let's do one more. Does this converge or diverge? Let's do the sum. Do summation notation this time. N is 0 to infinity. You'll see this isn't how we would write an infinite series here with this infinite symbol. Say we have a rule of 2/3 times negative 5/4 to the nth, right? And since my common ratio in this case, okay, remember this is my term, that's my common ratio, is negative 5/4. The absolute value of this is 5/4, and that is actually greater than 1. So since the absolute value of negative 5/4 is greater than 1, this thing diverges. Okay, meaning there is no sum, or the sum is just infinite. So that is that. I hope that makes sense to you guys. If not, I hope at least being able to tell whether they converge or diverge makes sense to you, even if it's hard to wrap our minds around. So that's all I have today. Hope you guys are doing well. Let me know if you guys have questions on anything, and I will talk to you later. Peace out.